In UniFi Network Controller, there are two different places where you can make DNS server settings. First one is under Internet. If you go to your WAN part, under menu, you can set DNS server here. And another place is under networks. For each network or VLAN, for example, the VLAN 10, go to menu, DHCP, expand the options. You can see DNS server setting as well. So you may wonder why there are two different places to set DNS server, what the differences are, when to use which one, and set the value to what, right? In your network environment, just within UniFi router, you already have two different DNS server settings. For each of your client, it has its own operating system level custom DNS server setting. And many people will run additional DNS resolver, for example, Pi-hole. In Pi-hole, you need to set upstream DNS server. Some people may even go further to host Unbound. In Unbound, you need to configure the DNS forward. Some of you may know within UniFi router, DNS mask is used to provide DNS service. It looks like a messy situation. So you may wonder at a single time which setting is effective, how they work together, and for each scenario, how we can set them properly. The most important thing for us is to understand how the DNS name resolving works within the UniFi router. And to achieve that, we have to go to the backend to check the configurations. So in the lower part of the screen, I have two separate Linux sessions. Let me SSH into the UniFi router in both sessions. For a Linux machine, the system knows the so-called name server or DNS server by checking the configuration file under etc folder. The name is resolve.config. This is used by Linux resolver. As you know, UniFi router is also running a Debian Linux. It also used the same file to get its own name server. Let me check what the setting is for UniFi router. Resolve.config file. It's very simple. See, name server is the local host. What it means exactly? Then let me quickly check what's listening on the local host IP address to provide a DNS service. I'm running the standard netstat Linux command. Try to find the process which is listening at the port 53 for DNS service. Let's check the UDP ones. So the very first one is already the answer for us. It's the localhost DNS server, right? If you continue looking, you can see the DNS servers for each single VLAN. VLAN 1, 10, 20, 30. The last one is for the layer 3 switch VLANs for VLAN 4040. So for each single possible VLAN, the DNS mask, which is shown here, is running a separate DNS server. The very first one is the one which provides service to the router itself, because in the router's resolve.config is pointing to this particular service, right? And what it means exactly, let's do some simple testing to see it in action. So in the left side SSH session, let me run TCP dump on the interface for localhost. The name is low. I only want to capture the port 53 for DNS. Okay, and then in the right side, let me do something, for example, digx.com. In the dig result, you can see the server is the localhost. It got 4 answers, 4 IP addresses for the same domain name, right? It was successful. And then in the left side, if you check what really happened on the localhost, you can see a client from localhost, which is the right side SSH session, asking this localhost DNS server, what's the IP address for x.com? And then the localhost DNS server replied, okay, these are the 4 IP addresses. So this confirms for this particular UniFi router, the name server used by the router's operating system is the localhost DNS mask name server. By the way, you can see these two new captured packets. It's done by the system, not by me. So something is trying to know what's ping.ubnt.com, and then it got reply. Then after about a minute, similar thing happened again, right? So which means, yes, the local host is used by this UniFi router internally for its own name resolving purpose. We just checked this smaller area for routers resolver config, right? It's within this file. It's pointing to this localhost. And we also confirmed from this netstat result, the process is DNS mask. You may think problem resolved. This is the answer for the whole video, right? No. For example, let me go to a random Linux machine, and in the left side, let me run the same TCP dump again. Then in the right side, let me dig fox.com. See, it got answer back. This time, the server is this one. It's the router itself. It's not the local host of the router. Keep in mind that this one is a separate Linux client, not the router's SSH, right? So that's why the DNS server is the router. That makes sense. But in the left side, you don't see the DNS query. So which means from the real DNS client, the DNS query is not really going through this local host DNS server. So we need to look into the configurations furtherly. From the right side Linux client's dig result, we can see the DNS server is from the router from this IP address. We already know from the netstat result for VLAN 10, the DNS mask is running a DNS server. So let me go to the DNS mask configuration file to find out how the DNS name resolving is done. The folder is under run dnsmask.config.d. Let's see what's inside. You can see for each VLAN, it has a separate DHCP configuration file, and then it has a separate DNS configuration file. Let me display the DNS configuration file. It specifies for this file interfaces, it's going to provide DNS service. We already know that, but from the whole file, we don't see what's the external DNS server the router will use, because in the end, the router need to forward the DNS request to someone else, to some real DNS name server, right? We don't see that information in this DNS mask configuration file. So we need to continue looking. If we run the DNS mask command to get the help, it will list a lot of options. One of them is interesting to us, resolve file option. See the description. If you don't specify it, the DNS mask will use this etc resolve config file, which we just checked. Of course, we know DNS mask is not using it. Otherwise, it will be a loop, because in this file it's pointing to the local host running DNS mask. So we know DNS mask must be using some other resolve file. Let's find it out. We need to know when the router launches DNS mask, what's the command line parameter provided, right? So let me run the ps command. I'm trying to list all the processes to see which one contains DNS mask. Interestingly, there are 3 processes, and the first one, you can see it's using the Ethernet 0 port, which is the 1 port. It's using a separate resolve file. In my understanding, this is for policy-based routing. If I'm wrong, please let me know, but this is not related to our video, so we will skip it. And then I see 2 identical command lines. They have different PID. In the right side, let me run the netstat command again and find the DNS related servers. See all the processes for DNS mask, they are this one, 147.327. In the left side, which corresponds to this one, right? Let's look into this particular line, which has the answer we are trying to find. How DNS mask even knows the external DNS resolver. Let me display this file. it's super simple. For Ethernet 0, it's using this name server, and for LO, it's using this name server. In this diagram, I simply show you how I run my home lab. It is behind another router. This router, main router for my home, it has the IP address shown here in the DNS mask configuration file. My home lab, it has its own VLANs, its own subnets. So that's why for the WAN part of my lab environment router, it has the .2 subnet IP address. The WAN side name server is set automatically by using DHCP. That's why you see this name server here. And we will discuss strange 1.1.1.1 name server later in my second video. Now we have found all the 3 crucial configuration files which are related to this video's topic, how the WAN part DNS server setting and the VLAN DNS server setting are related to each other. So let me display all the 3 configuration files on the same screen. Let's go through them to understand it. The router is a Linux, so it has its own resolver configuration file, which is this one, etc resolve config, and it's very simple. It simply points to the localhost. Then because we know DNS mask is running on localhost as a DNS server, right? How this DNS server and all other VLANs DNS server, how they get their DNS setting is through the lower left part configuration file. So from this file, in my case, it's my home network's main router. In your case, it may be your ISP's name server or whatever DNS server you use, right? So this is the real external DNS resolver. And in the lower right side, this file is DHCP configuration file, but it tells the DHCP client how to set the client's DNS server. See, this is the DHCP option for DNS server. It is my router's IP address, and because my router is also running a separate DNS service against this IP address, right? And this DNS server also get the DNS configuration through this DNS mask resolve file. That's how these configuration files are related. When you set your WAN part DNS server, you are impacting this lower left configuration file. When you set the VLAN DHCP server setting, you are changing the lower right part configuration file, and the upper right configuration file will remain the same. It will never be changed. In this way, your different web UI configurations will lead to different changes to different backend configurations. Now I believe many people are thinking, okay, for VLAN and for WAN, yes, they have different configuration files, but in real world, if I simply want to change the DNS server, where should I make the change? In the WAN part or in the VLAN, right? We will discuss that in details in my second video in different scenarios. But in this video, let's focus on one very simple scenario. For example, you just want to use Google as your external DNS name resolver. So then whether you set it in WAN or in VLAN, it's depending on 2 different things. First, in UniFi network controller, when you set the VLAN's DNS service, it's per VLAN, which means if you have multiple VLANs, if you want to have different DNS settings for them, then you have to go with the VLAN setting, because if you change the WAN setting, it will apply to your complete networks. That's the first point to consider. The second point is the UniFi router's local DNS service provides some additional functionality. For example, you can set the individual local domain name for each VLAN, and another example, for any DHCP client, if you go to setting, you can give it local DNS record. All these functionalities are achieved by using the local DNS service. If you bypass the local DNS service, you will lose these functionalities. As the last part of the video, let's go through 2 different settings. First, let's set the WAN DNS server to Google. Go to the internet setting for the primary internet, the WAN part. Go to menu for DNS server. Let me set it to 8.8.8.8, apply changes. Then remember in this slide I mentioned when you change the one part DNS server, what you are really changing is this resolve.dns mask file, right? Let's validate it in the SSH session. Let me display the resolve.dns mask file. Now it only has one name server for the Ethernet 0 part, which is the one part, and it is the Google server we just set. So we confirm the configuration file change. Then let me launch a Wireshark. This Wireshark will be monitoring the router's WAN part, not the LAN part, because I want to know what's the real external DNS name resolver used by my router. Let me start capturing. As you can see, I already set the display filter to DNS. By the way, even I haven't done anything yet in the Linux client, you already see a whole bunch of DNS queries. Where they come from? They are from the router to check the internet latency and to check the connectivity. If you are interested, search my another video. Let me do a dig yahoo.com. There's something captured already. Stop capturing. Then let's check the Yahoo related DNS queries. It's from the router's one part IP address, and then the destination is directly the Google 8888. So that reflects our changes, and of course we got the reply from Google. Nothing special, it's expected result. You can see from the diagram, because I haven't changed the VLAN 10's DNS setting, so my DNS client will still have this .10.1 router's IP address as the DNS server, right? The client sends a request to this one, and this DNS mask knows the external DNS server from the lower part configuration file, so then it sends the request to Google. Then let me start a new capturing. This time let me dig a external local domain name. Let me dig this client's own domain name, right? I know its host name is Debian-10, then followed by its local domain name I set in UniFi network controller. It is VLAN10.home.apa. Okay, so this is completely my local private domain name. Let me dig it. See, it got result back from where? From my own router for VLAN 10, and it got the correct IP address from the Wireshark. You don't see anything for this DNS request. It's not sent to Google at all. Why? From the diagram, you can see the client dig this domain name, and it's completely handled by the local DNS mask running for VLAN 10, and it's not sent to Google. So for both cases, it works if I set the WAN DNS server to Google. Now let's move on. What if I change the VLAN 10's DNS server setting? This time, let me set the VLAN's DNS server to Google. Before doing that, let me revert back the one part setting. Set the DNS server for primary internet to author. Then go to VLAN 10. For DHCP setting, expand the options for DNS server. Let me change it to 8888. Apply changes. Now the changes are effective. Let me show you the two different configuration files. First, this one about the WAN DNS setting. By the way, you may notice I checked this particular file, which I got from the DNS mask command line, right? In fact, it's linked to the same file I show in the diagram. They are the same thing. So let me display the file. See, this time it's changed back to what we saw originally. It has two servers. One is for one part, the other one is for RO. Then let me display another file for the VLAN 10's DHCP configuration file. Display the file. Let's see this line, which is related to the DNS server setting. It's correctly set to the 8888, reflect our UniFi network controller change. Then let's do the same thing. Let's dig the internet domain name and a local domain name. Let's see how it behaves now. Because we just changed the VLAN DNS DHCP server setting in the DHCP client, I need to force the refresh of DHCP just to get the new change, right? In the Linux client, let me disconnect, reconnect, and just to confirm the DHCP change, you can see the DNS server is 8888, right? Close it. Now let me dig x.com. Stop capturing. So let's see what happened. From the dig result, you can see the server. This time it's not my router. It's directly Google. And from the Wireshark capturing, you can see from the WAN part perspective, it's exactly the same as our first test, which is we only changed the WAN part DNS server setting, right? It is still from the router's WAN part IP address to Google. Interestingly, you see another DNS request to a different DNS server, the 1111. We mentioned there's a separate name server, right? We will briefly talk about that in my next video as well. For this video, let's skip it. And then from the DNS answer perspective, you can see it's exactly the same. It's from Google to the router's WAN part. So from the WAN perspective, from the internet traffic perspective, it's exactly the same, but internally within the router, as you can see in the diagram, the client completely bypassed the DNS mask internal DNS server. Instead, the client directly communicated with the Google DNS name resolver. That's the difference between this VLAN change and the WAN change. If we dig the local domain name, the exact same local domain name for this VLAN 10 Linux machine, okay, it got result back, but the answer count is 0, and the answer is from the Google server, even though the domain name is my private network's domain name, right? And then in Wireshark, you can even find the corresponding DNS request. It is from the router's WAN part to Google, and the question is, what's the IP address for this domain name? So this DNS query doesn't make sense because we know this domain name is not an internet domain name. Why this happens? Because we set the VLAN's DNS server directly to external DNS resolver. In the whole process, the Linux client doesn't know this domain name is private. The router does know, but we bypassed it, and the Google doesn't know the IP address. That's what happened. Okay, so this ends the video. We will have more detailed discussions in my second half video. Okay, thanks for watching.